In July, the North American Electric Reliability Corporation, also known as NERC, released a stark warning. America's power grid faces unprecedented challenges to its ability to keep reliable electricity flowing to homes, businesses, and the critical services our society relies on. You're listening to Energy Solutions, a podcast from the Electric Power Supply Association, where we showcase the voices and stories behind America's changing electric grid. I'm your host, Todd Snitchler, EPSA's president and CEO. On today's episode, I talk with Mark Lauby, Senior Vice President and Chief Engineer at NERC, to find out more about what's driving these reliability concerns and what needs to be done to keep the lights on as we head into winter and the years ahead. So, Mark, you've had a long career in the industry, and of course, everybody has a different entry point and a reason that they got in. Some people have a degree and are looking for a job. Other people plan on it. Kind of how did you get plugged into the energy and electricity space, as part of your career?
Well, that's a good question. I'm kind of lucky, actually. I was getting an electrical engineering degree, and I was looking for some work in the summertime, and I got tired of driving taxi cabs and working in Menards. And so I sent my resume over to the local power company, Northern States Power Company in Minneapolis, Minnesota, because I was going to University of Minnesota, and they forwarded that resume to the regional entity, which was called the Mid-Continent Area Power Pool at the time, or MAP, and now it's become the Midwest Reliability Organization. So I interned there, and then I finished my senior year with an emphasis in power and got my job there at MAP. And then, of course, worked there for about 7-8 years, and then joined EPRI, the Electric Power Research Institute, for 20 years, and then joined NERC. So reliability is in my blood.
So you are deeply vested in it, and we'll try to, you've got a lawyer on the one hand and an electrical engineer on the other. So we'll try and keep the acronyms down and the technical stuff to a minimum so people can understand what we're talking about. So
sounds great.
All right. Well, with that in mind, let's jump into, NERC's chief mission, which of course is power system reliability, and how we achieve it, how we work to make sure that it's insured, and really how we try to avoid outages. How do you think about reliability broadly? And then maybe we'll drill down into some questions about the summer assessment and then the upcoming winter assessment.
Well, as I look at the overall where we are today and where we're going, I see a significant transformation in the grid. The resource mix is dramatically changing, and we need to make sure that we manage that resource change and shift to whatever that endpoint might look like. So if I were to say what the state of reliability is right now, it's one that we're certainly watching. We are developing new standards to address the emerging risks that we're seeing from the new resource mix. And we're in those areas where we can't set standards, where we're talking to regulators at the state and federal levels to start asking them to start addressing some of the resource challenges.
So you mentioned some of the work that's done. You also put out a number of reports over the course of the year, and the one that really got folks' attention this year was the summer reliability assessment that came out. And I think the messages were familiar, at least to those of us that have read the reports in the past, but it certainly got a number of policymakers' attention. So can you kind of walk through what some of the key findings were in that summer reliability assessment, and then how you think the grid has performed over the course of the summer?
Sure, and you have to remember that the reliability assessments are not a prediction, but rather they're a risk assessment, and so we gather information from industry. We look at the different reserve margins. Then we also actually put them through some different tests, you might say, to kind of stress them. To see what might happen, and we start looking at some of the energy challenges that industry is facing, because as we go from the areas where we had firm energy from capacity, and now we get to energy constrained resources like variable generation. Well, what are the implications of that? And what we did see is one area specifically that really had we would consider high risk, because their generation capacity had reduced by 2.3% and from 2021, and yet their load was going up, and their markets were not generating additional capacity that were going to be needed to cover what we felt might be a bit of a shortfall in their reserve margins. And reserve margins are an indicator of the reduction of flexibility, during, especially when you have heightened challenges like high temperatures and therefore higher air conditioning loads, et cetera. Then we also saw other areas where we had an elevated concern, especially in Texas, in California, and Mexico, where especially heat events and drought were driving either the reduction in capacity because of water, and then of course the knock-on effects sometimes being in some of the extreme conditions resulting in fires. Right. So both of those three areas were ones that we're really concerned about.
I hadn't thought to ask you this, but you raised an interesting point about drought, which they don't come and go in a season. When you end up with a drought situation, it can be years long in the making, and the more serious the drought gets, the greater the impact potentially on the system. How is NERC thinking about some of those issues?
Well, of course, we first of all try to ensure that we're putting a spotlight on the challenge.
Yep.
And we like to on the short term see what the operational planning is, which is what are they going to be using from a demand response perspective? What do their imports look like? What does the transmission system look like on the short term? And then from a long term perspective. And then we start thinking about, well, how do we ensure that the system that's being built is going to be able to handle these kind of conditions? Because our view is climate change is occurring over time, and that climate change is driving more extreme weather, and that extreme weather is coming at the same time that we're building resources which are actually environmentally sensitive. And so ensuring that we have a good balance between imports, transmission systems, and a good mix of resources so that they have sufficient amount of reserves. And when I talk about reserves, I want to get beyond just capacity reserves, but energy reserves.
Right.
This is becoming an energy problem. It used to be that we would get energy because we had capacity. But now with capacity fluctuating and being uncertain, we don't always have the energy we need. So we have to have energy reserves. We have to understand where we're going to be able to get them. We have to understand where we may be deficit and where there might be excess energy so we can import, and vice versa.
Yeah, and I know that I have heard Jim Robb, your boss at NERC, mention that transition to think about it maybe from a different perspective, that a simple reserve margin isn't the way we may need to think about this problem.
Yes, life was easy.
Yes, if you could do the math.
You got capacity, you got energy, you got essential liability services.
Exactly.
Now that equation is split up, and we have to do each one of those separate.
That's right. So we're almost to the end of summer, and we're headed into the fall and winter. The fall usually, although that is changing, used to be a season where it was a little easier. We could catch our breath and then look into the winter. There's probably some things that you're watching. What's on your mind as you look at the winter assessment?
A couple areas. One is, of course, ISO New England. And
right.
Those of you that perhaps have seen the FERC conference up there, it's become very clear that they're going to be very dependent on LNG, especially if they have a cold winter. Yep. And that LNG, there's a lot of competition for that LNG across the world, especially in Europe. So we're watching that area very carefully and closely. And I think that's a result of this long-term inability to build more gas pipelines in the area, more transmission in the area. So we get this impact from I think a lack of infrastructure construction, and that may actually come back to who's responsible. Is it states or is it the market, and who's responsible for approving tariffs? So anyway, that's the long-term issue, but that's a short-term. We're also interested in the winter units and their preparations. We've sent out an alert again, as we did last year, as we are working with industry to write standards. We're keeping the conversation going with industry around being prepared for the upcoming winter, and then they'll be submitting their preparations, and then we'll be making some contacts with individual generating owners and balancing authorities to see what their plans are for the upcoming winter. So we're looking around in the Texas, SPP, maybe in the southeast areas. It's like. Yeah, I was up at the Mall of America the other day, and that's how a power plant's built in the Midwest, as opposed to, right, let's say, an open air mall, right? And that's how power plants are in the South. So how do we manage those differences?
Sure. And of course, we're all hopeful that we're going to make it through the winter unscathed, and that there won't be the kind of trouble that we've had in the past couple of years. So
hope is a heck of a deal, though. I'd like to get.
It's not a strategy, as Donald Rumsfeld said.
Exactly. So I mean, I hope it'll be a mild winter, but I want to get beyond that to something that says, I'm comfortable that we're prepared. Yeah.
So I want to, you've mentioned a couple of times now, intermittent resources or non-dispatchable resources, put whatever label on it you think is appropriate, but they're playing a more important role on the grid, both on its performance and assuring reliability. We're all continuing to see a greater amount of penetration of intermittent resources or non-dispatchable resources. So how do you think about how we keep moving the energy transition forward while maintaining the focus on reliability? Because it's clear those resources are coming, but it's also clear, as I like to say, that people still want their lights on, beer cold, and water warm.
Yeah, I look at it in two different ways. One is, of course, ensuring that that when these devices are interconnected to the system, that they're contributing to reliability. And we've been having some experience there where some of the interconnections have not been as robust as they need to be, and sometimes they go away just when you need them during certain kind of fault conditions. So that's got to be fixed for sure. And I think the other is, we have another set of rules of thumb of who has to follow NERC standards and contribute to reliability, ride through events, et cetera, and who doesn't. And it's these old numbers of 20 megawatts for a plant and 75 megawatts. That's 20 megawatts for a generating unit and 75 for a plant. We're going to be working with industry to reevaluate those rules of thumb. And see what makes a lot more sense, and also looking at the distributed generation as well, because as more generation goes on to the distribution system, if the bulk system's dependent on that for reliable operation, be it for essential reliability services or energy, then we need to also be looking at what our expectations are there as well. So so I look at it in two ways. One is making sure that once it's interconnected correctly, and second of all, making sure we know who's responsible, who's going to be doing what to support reliability. And we got to get in front of this one quickly, because as you are mentioning, Todd, this idea of looking at the queues of generation throughout, especially in the market areas, it's really heavily apportioned toward photovoltaics. So we've got to get it right. If we don't get it right, it will actually stumble the transformation, and it'll set us back. And in some cases, we might end up find ourselves in a corner that we're going to have to build ourselves out of, and that'll be very expensive. So we got to manage it right.
Yeah, we completely agree with you on that the transition's got to be an orderly one, because if you get things out of order, and this is the lawyer, not the engineer, but if you get things out of order, you potentially set the system back. And if we want to have that steady progress forward, we've got to make sure we get it right. So
it's got to be managed, and that means
that's right.
There has to be an adult in the room that simply says, I know the market's not necessarily supporting this, but this is something that has to stay around to support reliability as we transform. We talk about natural gas. I mean, hydrogen and fusion have been 10 years away from my whole career. I don't know what that next fuel is. I know that for long-term, wide-scale events, I don't know what that long-term firming fuel is. I know batteries can play a role. I know transmission can play a role, but we need to also be understanding that the kind of events we're seeing, which are not going to be rare, but could be widespread, and you can't count on your neighbor anymore. How do we make sure we firm up that energy?
Right. It feels like we're still planning for the way the grid used to operate with the planning parameters that we're using, and we're forcing the system into a new state of being based on the resources that are coming on. Has NERC given any thought to modifying the planning parameters or thinking differently from an engineering perspective about not using just the 50-50 standard, but moving to a 70-30 standard? Or is it, 1 in 10 loss of load event, or a 1 in 20 loss of load event? Or is that something that is not quite on the agenda that you're thinking about? Or yes, we are, but I don't want to talk about it.
So this could be a wide-ranging conversation.
Sure.
When it comes to the 1 event in 10, which started really back in 1947 with Calabrese, and then a guy named Whitlock, I think, came up with this idea. Well, about 1 in 7, 1 in 10 years was a reserve margin, would produce a reserve margin that you'd be comfortable with. And I guess it's very engineering-ish to say 1 in 10 or 1 in 100, but that didn't really take root until after the 1965 blackout. Which then PJM said, we're going to do this to 1 to 10, and that'll give us a lot more flexibility in the units that we have. But again, that comes back to this idea that I don't have to worry about fuel.
Right.
It's just the capacity is 100 megawatts is 100 megawatts a day in and day out.
Yep.
Now we start adding in these nameplate variable resources, which have uncertainty due to the fuel availability. And even if you kind of start discounting them by 20% or whatever else, they may be zero at certain times when you need them the most. And so how do you firm them up? So this really kind of transitions the conversation beyond what I like to think of as capacity is king, that actually the king has no clothes. Energy is king. And so we have to start developing metrics around energy.
For those who may not be familiar with the terminology, capacity is the maximum power output a generating resource is capable of producing. Energy is the amount of electricity a generator actually produces over a period of time.
So when you start looking at our assessments, you'll see that we're doing a number of things. We gather data on the 50-50 as traditional, but then we also look at 90-10 conditions and even maybe above 90-10. If you saw what happened, for example, when Uri, load was much higher than even 100% forecast. So we really start stressing that system. And second of all, we're adding duration, so we can start saying, oh, well, this is a 2-week event. And not just a 1-hour event. And so that we can start again stressing that system more. The cost to the consumer is kind of very small, and then it's like a hockey stick. All of a sudden it gets very expensive. So we have to look at durations that take us beyond just the traditional 1-hour event and start thinking about days and what are the implications of that. So certainly that's one way to look at from a capacity energy perspective. And then I do like what FERC put forward on their NOPR on how we look at how planning the transmission system. And really it takes us from this idea of, okay, the 1 day in 10 and the reserve margins and the load, and we're looking at scenario planning. Now, what scenarios make sense? Maybe you can look at climate change models, and that might drive different types of weather conditions that you might want to be studying. So you can bookend the problem and say, I want to be able to build at this level and recover after that level. Because as you know, it's hard to build for 100%, but then you have to understand how to restore from those. And these kind of events are a lot different than, let's say a tornado or a hurricane comes in and you got your mutual assistance and everybody gets in a truck and they drive to the problem area and put up the poles again. When you have when you're losing resources like this and they become unavailable, you just got to, you almost get to a point where you just got to wait for the weather to change.
Right.
And so you got to be in front of that and understand what the implications are, and then also get the consumer engaged a little bit more. So if they look at alternatives, should they be putting in backup generation, or looking for other options available to them? I think it's when we look at how we plan the system, it'll become much more scenario oriented, much more energy oriented, so we understand what the implications are. I just believe that climate change is going to continue to roll forward, even if we got ourselves into that zero carbon world, because we have other countries that are growing very fast, using a lot of fossil fuels, and until they find their renewable future, that I think this is a climate change is going to continue at some rate.
Yeah, and those extreme weather events are very impactful, and it's not just the cold temperatures, or it's not only heat, it's the wind droughts, it's the cloud cover.
Absolutely. And also the events that we never thought were extreme. Like a cloudy month of March. That's just a March in May in Minnesota.
Right.
A whole month of clouds. It's not like, that's an extreme weather event, but now it becomes extreme.
That's right.
Because of we're counting on photovoltaics or the high winds that take you to cutoffs. And so you're right. It's cloud cover, it's smoke, it's smog, it's high temperature, low temperature. It's a common condition that impacts a broad array of resources that are sensitive to that weather condition. We need to model those and look at different size of area sizes and durations, and then understand, well, now where am I going to get my energy? Is it going to be transmission? Is it going to be the break glass generation that Jim talks about? Some sort of backup that you pay to have there until such time as you have something better. And I think that we have to look at all of these options, because one thing is for sure, the consumer is, as you said, is very reliant And that's one of the reasons why this job is so important.
More so than ever.
So excited. And your job and my job is to make sure that we provide reliable, safe, and affordable energy to the public, and that's their way of life, and they're depending on us, all 400 million people in North America.
That's exactly right. So we've kind of talked around it a little bit. So let me just ask you directly, because you and I have been dancing around this issue ourselves for at least a decade around electric gas coordination. So it's an issue that has certainly given rise to a lot of discussion. There's been a FERC-NARUC collaborative on it years ago that Phil Moeller, when he was still at FERC, and I participated on when I was at the Ohio Commission. We have had meetings convened at NERC. I think Jim was still fairly new, and he said, we have admired this problem for far too long. We need to actually work on solving it. And it's been a bit of time since those conversations started. So, A, do you think the situation is improving? Like, are we making any progress on gas electric coordination? And B, regardless of your first answer, if you could fix the problem, what do you think the solution set needs to look like to resolve some of these gas electric coordination issues?
Well, as a reliability person, you tend to sound a lot like a dirge all the time, but actually I'm kind of an optimistic person. I think that what we learned in the recent Texas event, I think what gas industry learned as well, a little bit more, and though I know when Phil Moeller was talking about it, he was pointing to this as well, as this interdependency, and it's actually dependency. First time, for example, load the impacted the reliable operation of the bulk power system by not serving that load, as opposed to cut load. It was supposed to actually make you more reliable.
Right.
The bulk system remains stable. That actually made matters worse. So if you think about the industry itself and how NERC was formed, was to address the risks from interconnection. That that your neighboring utility is going to be doing certain things that you're going to be doing.
Yep.
I think that is the glue that brings together the gas industry at the seams anyway, and the electric industry. I think the FERC's leadership around the forum idea with NASB is a very good starting point. I was at their recent board meeting, and they're optimistic. Excuse me, that things are going to change now. And so the conversations are being had, and I think that there's going to be standards needed there, so that the gas industry can know what they can depend on the electric power industry for when they're depending on them for compressors or keeping them warm, and vice versa. What can be dependent on the gas industry as well. And if I could wave my magic wand, the gas industry was really formed in a different way than the electric power industry, and there wasn't an interdependency for a long time.
Yep.
Then there was an opportunity for especially IPPs and to plug into local gas pipelines and take advantage of the triage that was available, excess gas in the pipelines, and get into the marketplace, as well as I think there was some regulation. And then finally, gas became so inexpensive for a while there. It's not so much now. But there's some places where they wish they could run their coal plants because gas has gotten so high that also drove out a lot of the other fuel types. So now we have kind of a gas system that's not really built to serve the electric power industry per se, and in many times some of these markets, everybody's buying gas on spot. And there's not an incentive to build more gas pipelines. So I would love to be able to have see the same kind of philosophy around reliability and construction of infrastructure that you can see, let's say, in a transmission system.
So I think I heard you say we need more natural gas infrastructure.
Yeah.
And certainly, if we're going to continue to see the additional decarbonization of the grid, as well as greater penetration of renewables, I think, I don't know if it's your study, but I know there's been studies by a number of organizations that are credible. They've done a credible analysis of it that says you're going to need even more natural gas fired units than you have now. They may not run, 24/7, but when you're going to need them, you're really going to need them, and they've got to have that ready supply. And on that, we certainly agree.
Yeah, I think that's the only. Some people call it the bridge, but then it's the bridge to where. And so to me, I know we look to talk at 10 years, 15 years. And then I guess that means we just got to pay for the pipelines and the power plants in 10 years, 15 years. If in fact we're going to be at 2032 and be this, zero carbon, or 2035, I think it's a much longer bridge. We hear talk about other technologies like small nuclear reactors, modular nuclear reactors, and we talked about hydrogen and fusion and all these, and they all sound wonderful, but I just don't see them, and from a technology development perspective and deployment perspective at scale in the next decade. To be honest with you, we have to be straight with people and say this is going to take longer.
Yeah, and we certainly appreciate the candid conversation. That's what we've tried to do, is say we're here to help you, but there's a way to do it right, and then there's a way to do it wrong, and we want to be in the right column. And I know you guys are on the same.
Absolutely, page. We can't just sit back and applaud every time a coal fire or gas fired plant retires,
right?
And then without understanding the implications of that, and making sure that perhaps we keep some of it around to support the uncertainty that we're getting with the transition to renewable and variable generation. Now, I know it can be firmed up with batteries, but batteries are 4 hours. And at some point, you're building more solar to charge more batteries, and then you kind of get to diminishing return there.
Right. How do you think about unifying the reliability while addressing climate change issue?
Yeah, and I think it's a matter of getting down to the fundamentals, which is, what are some of the basic rules of thumbs and how we built this system, and then looking in the future and realizing that the society is going to be more dependent now on electricity as we drive out carbon in the transportation sectors and in the manufacturing sectors, and all that, more dependent on electricity. So actually reliability has to increase.
Yeah.
Because that dependence is going to be there, and you can't afford the nuisance of momentary, nevertheless long-term outages at the same time that you're adding in a lot of uncertainty on the fuel side.
Mm-hmm.
And so the way in which we look at it and working with industry is developing those scenarios. What are we going to be planning that system to? What is the design basis of this system? I could tell you before what the design basis was. We have a standard. It talks about how you're going to build your transmission to be able to withstand certain types of fault conditions and certain types of stability conditions. We need to now layer on top of that Mother Nature, because Mother Nature's playing even more of a significant role than in the past, because she's impacting now our resources as well as our transmissions, not just a line to ground fault that's caused by lightning, but also now we have widespread cloud cover for a couple of weeks. So how do we build that system out, considering how dependent society is going to be on this. So bringing industry together to identify what are those scenarios that they're going to build to, what is going to be that new design basis, and then codify those in standards, so that it's not something that we think about and we throw away and forget about. They have to keep the conversation going, and the way we do that is through industry set standards.
It certainly sounds like an overwhelming issue. So I'm glad there are smarter people than me that are thinking about it, because there's a lot of moving parts in a lot of different, and the country's regionally variable. The resources are different. So I'm glad.
And jurisdictionally too. We talked about the gas electric jurisdiction, but then we have the distribution bulk system jurisdiction. And I'd like to just kind of throw all those jurisdictions out the window. Now let's talk about reliability of the bulk power system. And now let's figure out how we make that system reliable and to what level we're going to make it reliable. And then we'll figure out jurisdictions after that. Yeah. Otherwise, you get hung up into that kind of no, you can't do that. Well, if we can do under frequency load shedding on the distribution system, we can certainly look at the distributed generation there.
Sure. We've referenced the bulk electric system a number of times. Can you explain to listeners that may not be familiar with what the bulk electric system is, how NERC defines that?
Yeah, it's defined at levels that are at a voltage of 100 kV and above, kilovolts and above, and plants that are 75 megawatts or higher, and generating units that are 20 megawatts or higher. Those are the kind of like the rules of thumb. And of course, now those are all being called into question as we look at this dispersed, decentralized generating system that's digitized across the network. And that BES then needs to follow certain standards. of reliability, which are performance-based and codified by industry. Yep. That writes them, votes on them, and says they're going to follow them and need to comply with them.
Great. Thank you. That'll be helpful. I'm sure people will say, what is that again? And now we've explained it. So as if you don't have enough on your plate, cybersecurity is also an issue that is of growing importance, and it's a critical component of NERC's work as well. What are some of the issues that NERC's either flagged on the cyber front, or is something that you're paying attention to, or it's an evolving threat matrix that you're looking at, or what needs to be done better?
And of course, to a certain extent, a bit in conflict. And I'll explain that a little bit. First of all, of course, what we are doing is we have a wonderful facility in EISAC, which is our energy information sharing organization, where industry shares information about attacks that they're seeing, most of them on the business side, and what kind of attacks they are, and what are some of the mitigations. And so it's become kind of a clearinghouse of information exchange. They have, of course, these appliances that are out on the business systems, and now they're developing appliances for the operational technology. That's your breakers and your substations and where all that computerized equipment is out there, and testing some of those. So we'll be able to monitor the ongoing cyber, you might say, status of the system, and provide that information to the industry, and do a lot of deep analytics on that. So that's kind of like the operational side. But I always look at the world also from the planning side too, and that is, how do I plan a system so the operator has less to worry about?
Right.
And so we've also stood up a group that is working with industry, and I think there'll be a guideline here posted soon, talking about, well, what are some of the design considerations when you are designing your system so that you can de-risk the system, you can make it less likely to be impacted by cybersecurity, and also that it kind of contains the risk. And so I expect will establish some planning standards down the road as well. And what I mean by conflict now, as we start thinking about this decentralized grid that's digitized and has industrial controls across the grid, well, then you also want to make sure you do that in such a way that you don't increase the attack surface.
Right.
Otherwise, you're actually going from one danger to another. Sure. And I know the industry has worked very hard on misoperations of relays. Now you can imagine if we take that, magnify that even larger with control systems across the network, and controlling different photovoltaic arrays and all that, and to make sure that we do that in such a way that it's cyber secure. So that's a kind of I call it a new science, and a kind of a engineering science around cybersecurity for the operational technology of the bulk power system.
Yet another issue that sounds like it's, very broad, very challenging, and is layered on top of these other things. So again, there's an awful lot on your plate and on NERC's plate as you look at how we can ensure that reliable operation of the system. So
yeah, these are like two major areas that if you simply say, well, we're going to continue to do what we do to remain reliable. Now we have to change the way in which we work in the energy challenge, and then the cybersecurity and physical security area.
Knowing all that, and now having talked about some of those very broad challenges that you're having to wrestle with, what is it you'd like policymakers to know or to think about as they're making decisions that ultimately will impact the grid and how it functions, and what resources are on that grid, and how we have to try to ensure that safe, reliable system?
Yeah, I think I think we kind of talked about it before, and that is making sure that it's done and managed in a reliable way. In other words, not just trying to drive out all of the fossil fuels to this new arena of green technology, which will ultimately not succeed unless there are sufficient amount of firming resources behind it. Yep. And I think that kind of conversation needs to be had. I think we need to bring everybody to the table. I mean, if I were to look at, a moving forward position, we need the regulators there. We need both state and federal regulators there, and provincial. We need the gas industry there, the electric industry there. We need the ISO RTOs there, all talking about how we're going to make this transition It can't be fragmented, and it can't be we're going to retire on time and we're delayed on construction of the new stuff. We need to make sure we manage this transition so we don't kind of build ourselves into a corner like we talked about before.
Yeah, because if you're in the corner, you're already in trouble, and there's no quick fix to that.
There is no quick fix, and you have to start spending a lot of money to get out of it. That's right. And I look at some of the conditions I see, and I'm worrying that we're getting into those conditions.
Is there anything else that you think about that maybe listeners would be interested in knowing about how you're thinking about the system?
Well, I think this is going to be a huge partnership. It's something that, as I mentioned before, we need to bring everybody together, and it can't be we can't be sitting around and finger pointing. We know that 215 basically says the states have the responsibility to build a sufficient amount of transmission and generation capacity. We know that's for a fact. We're working on the energy problem to ensure we understand what the performance of that capacity is going to be. But in the end, if ISO RTOs and markets are going to be successful, and they're going to address this through either sending tariffs to FERC and asking for approval for long-term investments in the market areas to support the transition, those have to be considered. So we need to bring everybody together and talk about really what is, I know there's a fair and equitable challenge here, but then there's also a huge reliability challenge, and they can't be perpendicular. They have to be supportive of each other. So that's, I think, is something we need to be thinking about as we start rolling out some of these policies. It's one thing to provide incentives for different types of technologies, but as you drive other technologies out using those incentives, you got to make sure that you do that in such a way that the endpoint is not just I understand that we want it to be a green endpoint. We also want it to be a reliable, secure, and resilient grid of the future.
And I think that's a good point for us to leave it, because we agree with that wholeheartedly about how we have to commit to those. And certainly we have tried to make an effort, and will continue to do so, to be a good partner in the process, because we, as just like you, want to keep the lights on. When the lights go out, it's bad for everyone, and we want to avoid that. So Mark, I want to thank you for your time. We certainly appreciate it. We're grateful for the work that you do and for the relationship that we have, and the ability to try to ensure that the entire system, and for folks that may not have caught it a couple of times, Mark mentioned the provinces in Canada and Mexico. NERC is the North American Electric Reliability Corporation, not just for the United States. So they have an even broader remit than just the 50 United States. So thank you, Mark. We appreciate your time.
Thanks for having me, Todd.
Building a cleaner and more reliable energy future is not just an aspirational scenario. It's grounded in engineering and technical realities that must be faced. Meanwhile, discussions about how to keep the power system reliable continue, from state legislatures to RTOs to Capitol Hill and federal regulatory agencies. EPSA continues to pursue and advocate on behalf of market-based solutions to help ensure our member companies can continue to provide competitively priced, reliable power generation to consumers and critical services. You can find our analysis at epsa.org, and of course, NERC's report and more is available at nerc.com. Thanks for listening to Energy Solutions. If you like this episode, please share it on social media or with your coworkers, friends, and family. You can also connect with us on Twitter at EPSA News and on LinkedIn. And subscribe, follow, leave a rating, or comment on Spotify, Pandora, Google, or wherever you listen to podcasts.
Energy Solutions is brought to you by the Electric Power Supply Association. EPSA represents America's competitive power suppliers, which bring about 150,000 megawatts of power generation resources to customers throughout the United States. Discover the power of competition at www.epsa.org.